In this problem, we need to transform the Cartesian equation y squared times a minus x equals to x squared times x minus 2a into its polar equivalent. Let us begin. We'll start with the fact that whenever we have the Cartesian coordinate x and y, so x can be represented in terms of its polar equivalent as r cosine theta. And we have y, so y is represented by r times sine theta. So what we'll do, we'll use this corresponding x and y values in terms of its polar form and replace this into our given equation. So that means our equation, which is y squared times a minus x equals to x squared times x minus 2a. So this will now become y squared is r squared sine squared theta multiplied to a minus r cosine theta will be equals to r squared times cosine squared theta whole multiplied to x is r cos r theta minus 2a. All we've done is replace the value of x and y with the corresponding values. So let's further simplify. We can factor out r squared from both sides. So we have sine squared theta multiplied to a minus r times cosine theta equals to cosine squared theta times r cosine theta minus 2a. Then we have a times sine squared theta minus r times cosine theta times sine squared theta equals to r times cosine theta times cosine squared theta minus 2a times cosine squared theta. Fine. So what we'll do, we'll combine few terms. So we will keep a sine squared theta on the left hand side, but this time we're going to transpose negative 2a cosine squared theta to the left hand side, so it becomes positive 2a times cosine squared theta equals to, we will transpose negative r cosine theta sine squared theta to the right hand side. So we have r times cosine theta times sine squared theta, and we have this term which is positive r cosine theta times cosine squared theta. Fine. Let's further simplify. Now what we can do, we're going to use a trick here. We have a times sine squared theta. So we'll split this into two parts. So we get a cosine squared theta plus a cosine squared theta. This will be equals to, we're going to take r cosine theta as a common factor from both the two terms. So we have r cosine theta multiplied to sine squared theta plus cosine squared theta. And we're going to combine the first two terms by taking a as the common factor. So here also we have a times sine squared theta plus cosine squared theta plus a times cosine squared theta. So let's keep it aside. So we have r cosine theta multiplied to sine squared theta plus cosine squared theta. Now we have a standard identity on both sides. We have sine squared theta plus cosine squared theta. So that's a standard trig identity with a value equals to 1. So that means we have a multiplied to 1 plus a times cosine squared theta equals to r times cosine theta multiplied to 1. We are now left with a plus a times cosine squared theta equals to r cosine theta. So let's rearrange the term. So we get r cosine theta equals to a. We're going to take a as the common factor. So we have a multiplied to 1 plus cosine squared theta. So this is the polar equivalent of our original equation, which is given by a y squared a minus x equals to x squared times x minus 2a.